Physics Day 3, trigonometry problems. Sometimes they're called SOHCAHTOA problems, as you've probably learned in geometry class, where the S stands for sine, is the ratio of the length of the opposite leg to an angle to the hypotenuse, the length of the hypotenuse of the triangle. C is cosine, length of adjacent leg to an angle to the length of the hypotenuse, and T is tangent, the ratio of the length of the opposite leg to the adjacent leg of that angle to each other. So first you have to determine, do you have a right triangle? Which we do. And if we look at this 42-degree angle, the 16.5 is the hypotenuse, which means we'll probably be using sine or cosine because those are the ones that use hypotenuse. All right, then the x, which we're trying to determine, is adjacent to the 42-degree angle, so that's indicative of cosine. So we'll be using cosine. In other words, we'll be using cosine. Now here's what I expect you to do on a test or in class, is write down the initial setup. In other words, I'd expect you to write this down. The cosine of the 42-degree angle, and I want it exactly like this, equals, and I want an equation, that means an equal sign. The cosine of the 42-degree angle is the ratio of the length, the x, over 16.5. You can put the units back in at the end. So I expect to see that. I'm going to circle that right now. That's not the answer. But I expect to see that on your page. That's the setup of the problem. And make sure your calculator is in degrees, not radians, when you do these problems. And now I will let you just solve the problem. Basically what you'll be doing is multiplying both sides by 16.5. In other words, here's a step that you don't need to write down, but it would look like this. X will be equal to 16.5 times the cosine of 42 degrees. So you go to your calculator and punch that all in. You'll get x equals, now the question is how many sig figs here? The 16.5 is 3 sig figs, but the 42-degree angle, and angles are a little weird, but it's 2 sig figs. So we want to round our answer off to 2 sig figs because the 42 is the lesser number of sig figs, and the numbers we're plugging in here, which would have been our measurements, 42-degree angle. So we're going to round off to 2 sig figs here. That comes down to 12 meters. All right, I'm going to jot down another problem for you to practice with. So set this up and solve for x, and then we'll check your answer. You should have used tangent because you have the adjacent and opposite legs for the 71-degree angle. There's what I expect to see. The equation tangent of 71 equals x over 14, and then the x equals 41 meters. 2 sig figs because the two input values, or the minimum number of sig figs and the input values are 2 sig figs, so you round off to 2 sig figs. Next example. Let's set the problem up, determining whether it's sine, cosine, or tangent. If you look at the 16-degree angle, x is the hypotenuse, so that means it's either sine or cosine, and then the 7.25 is opposite the 16-degree angle, so we have the opposite leg and the hypotenuse. We'll be using sine. Alright, so what I expect to see on your paper is something like this. Sine of 16 degrees equals the ratio of 7.25 centimeters over x. You don't need to circle it, I'm just circling it because I want to see that on your paper. An equation, an equal sign with expressions on either side like I have, basically identical to that. Now this one's a little bit more difficult because of the x in the denominator of the fraction on the right hand side. Essentially, if you go through all the algebraic steps, you can do this all in your head if you want to, but it's a little bit more difficult. You end up with this as your final step before the computations if you write down all the steps. 7.25 divided by sine of 16 degrees. Essentially, when you move the x over to the left-hand side, it becomes in the numerator, and the sine 16 goes into the denominator because when you move things around like that, those all follow the rules of algebra, and you get this equivalent statement. Anyway, then you just plug it all in your calculator, and 2 sig figs for the answer once again. Because of the 16 degrees, this comes out to be 26 centimeters. Circle that. So the two things in circles are what I expect to see. Here's another sample problem. Solve for x, show your work, and we'll check your answer. So you should have gotten 4.3 centimeters. Once again, I have the important work circled. That's what I expect to see. 2 sig figs because the nature of the given data is 2 sig figs. Here we have a situation where we need to find the angle given two of the sides of the right triangle. So in a sense we're working backwards. And here it is. Figure out or determine the value of theta. I'll give you a second and then I'll show you how to do it. Alright, so that was more than a second, but bottom line is there's what you need to see, and that's what I need to see in those two blue circles there. It's a cosine problem because the 3.3 is adjacent to the angle and the 7.5 is the hypotenuse. And that's what I need to see. Theta comes out to be a 2 sig fig answer, 64 degrees. One more example. Alright, last example. Some might call this a trick question. It's not, but it's a little different. So just watch for this. It's actually one of the easier ones. This is just a straightforward Pythagorean theorem problem because we have two of the sides of a right triangle. This is just straightforward a squared plus b squared equals c squared. In other words, in this case, x squared plus 13 squared equals 18 squared, where 18 is the hypotenuse. So you can show extra steps. Well, once again, I want to see that step like that. Don't do any squaring yet. Write down the equation, and then you can skip all the other steps if you want or write them down. But bottom line, don't forget to take the square root at the very end. In this case, I believe x comes out to be 12 inches, rounded off to 2 sig figs. That's all I need to see. Like I say, if you want to put extra steps in there, more power to you, but I need to see those two steps. Don't do any work, just write down the equation with the numbers, and then the answer is fine. One more final sample for you to do. So here you go. It's another Pythagorean theorem problem because it's right here next to this one. Just watch out when these are mixed in with other sine and cosine trigonometric problems, SOHCAHTOA problems. But it's just, well, go ahead, you try it, and then I'll show you the solution. So the final answers, and once again, in the blue is what blue circles is what I expect to see. A 1 sig fig answer because 5 and 8 both are one significant digit. But if either one of them is 1 sig fig, the answer should be 1 sig fig. All right, we'll practice more in class.